As we continue now with our 3D N particles, try to make a continuity from where we left off. And E stands for exponential. This is energy. Time. So H. Let's move on to photo emissions. And here we have photo emissions, and that is relative to photons emission. Remember I told you about making the natural environment as a laboratory for me. Over the past 10 years, I have made the natural environment, logging lightning, the phenomena of lightning, that lightning, that you see strike in a thunderstorm and all of that. Physically logged it in a book, and sometimes on my portable smart phone, wherever and whenever it happens, the time and what type of emissions. Like, let me make an aside here. We have this type of emission, I call it lambda. It was a number 7 emissions. There was a broadband emission. I call that BB-IPE. Number 7 IPE. Lambda IPE. These are natural physical logging of lightning and the time when it occurs, usually during a hurricane or before a hurricane, when the whole stratosphere is black, and then the lightning come through, make a logging of that and the time and so on. And this was to give me a tangible hold of what was happening during the integrated photons emission. And you have discrete and integrated photons emission. And there was a whole bunch of it. You have MIPE, you have broadband, you have diffuse IPE, and you have natural IPE, and so on. But you could see over the internet, I've made a lot of posts on this. But that was an aside. Let's go back to our photo emission here. And what we have here is Km equals max kinetic energy F equals frequency this is omega, and this is the work function. H equal Planck's constant Remember we talked about the Planck-Einstein equation. Planck-Einstein equation. Combination of Planck with Einstein here. F equals frequency of incident photon. Frequency of incident photon. And the dimension of that is second to the minus 1, h of z. And K equals kinetic energy of the photon. And come up now with the equation that K, write it big, is equal to Planck constant times the frequency minus omega. This is all for photo emission and the photoelectric equation. Photoelectric equation. Now threshold frequency. And work function. Psi and omega. Work function of the material and the photon. We have f of 0 and r of 0 equal threshold frequency. And the unit will be h of z equals second to the minus 1, which is equal to 1 over seconds. Or per second. Now this equation can only be found by experiment, and the Broglie relation give the relation, the Broglie. So these can only be found by experiment. And it gives the relation psi, it's equal to Planck constant and the fundamental frequency, or HF0, which is the threshold frequency. Move on now to photon momentum. Momentum is mass times velocity, right? So it will be the mass times the velocity of the photon. And we have know that rho is equal to momentum of photon, and F is equal to frequency of photon and lambda is equal to the wavelength of the photon. And then we have the equation now. Rho is equal to time constant frequency over the speed of light, which is equal to h lambda. And your paper is run out again. A good time to take a break. Let's leave a mark in here so that we begin here on our next occasion, which is the quantum uncertainty equation and the Heisenberg uncertainty principle.